All right, let's talk about one of the biggest, most persistent puzzles in all of physics. For decades, we've had a standard, but frankly, pretty strange answer to a fundamental question about our universe. But today, we're going to explore a radical new solution, an idea from a series of papers that reimagines the cosmos not as empty space, but as a single physical substance.
So here's the puzzle. Why is the universe so unbelievably smooth? I mean, when we look out in any direction at the largest possible scales, everything looks pretty much the same. But how on earth did it get that way?
Well, our key piece of evidence is this map. This is the cosmic microwave background, the CMB. You can think of it as the oldest light in the universe, a kind of fossil left over from just after the Big Bang. And the astonishing thing is, it's almost the exact same temperature everywhere we look, right around 2.7 Kelvin.
And when I say almost, the level of precision is it's mind-boggling. The little fluctuations in temperature are tiny, only about 1 part in 100,000. To put that in perspective, that's like measuring the entire surface of the Earth and finding it's perfectly smooth down to a millimeter. A uniformity like that is just baffling.
And here is the real kicker. You see that spot on one side of the sky and that other spot on the complete opposite side? They are now billions of light years apart. According to everything we know about physics, there's been no time, not since the beginning of the universe, for light or anything else to travel from one side to the other. So how in the world could they have ever exchanged heat to settle at the exact same temperature? And that is what scientists call the horizon problem. It's a massive paradox because it seems to completely violate the cosmic speed limit, the speed of light. To solve it, you either had to get those regions way closer together in the distant past, or you need some way for information to have traveled faster than light.
Now, for the last 40 years or so, cosmology has had a go-to answer for this. It's a theory you've probably heard of called cosmic inflation. The logic goes something like this. In the very first fraction of a second, the whole universe we can see was just a microscopic patch, so tiny that everything was touching and could easily reach the same temperature. No problem there. Then, and this is the wild part, space itself underwent this period of insane exponential expansion, stretching that tiny uniform patch to the cosmic scales we see today.
This quote from the source paper really nails it. And look, inflation is a brilliant mathematical idea, but it has one catch. It relies on a hypothetical thing called an inflaton field, which we've never actually observed. It works on paper, for sure, but some physicists can't help but wonder if it's just an elegant patch. Is there maybe a more direct, more physical explanation?
And this is where things get really, really interesting. This brings us to a completely new picture of the universe from a theory called Hydrodynamic Quantum Cosmology. It asks us to forget about an explosion in empty space. Instead, what if the Big Bang was actually a phase transition? What if space-time froze? To get your head around this, you have to first just imagine the primordial universe, not as a vacuum, but as something with actual substance. Specifically, imagine it as a superfluid, a liquid with zero friction, zero viscosity, that existed before the rules of geometry as we know them. In this view, space-time isn't the stage for the play, it's one of the actors. So the Big Bang wasn't an explosion at all. It was the moment this supercooled liquid vacuum started to crystallize. The universe didn't start hot and dense. It started at absolute zero and released a tremendous amount of energy as it froze, creating the hot, dense state we recognize.
So, how does a freezing universe solve our horizon problem? Well, this is where the core idea of the acoustic horizon comes in. It suggests that the cosmic speed limit itself wasn't always what it is today.
This new model says the speed of information depends on the state of the universe. So before it froze, back in its liquid phase, information didn't travel as light, it traveled as sound waves, pressure waves. And in that incredibly dense primordial fluid, the speed of sound was, for all practical purposes, nearly infinite.
And that is the absolute key. Before this phase transition, the entire cosmic fluid was acoustically connected. These super fast pressure waves could mix the whole volume, smoothing out any temperature differences almost instantly. It's like stirring a giant cup of coffee with an infinitely fast spoon. The whole thing becomes uniform in a blink. So the speed of light, that number we all treat as a fundamental constant, in this model, it's just the speed of a particular kind of wave, a ripple propagating through the solid, crystallized spacetime we live in now. The ultimate speed limit dropped catastrophically the very moment the universe froze.
So let's just compare them directly. The standard inflation solution takes a tiny, pre-mixed region and just blows it up. The Acoustic Horizon solution says the entire volume was mixed all at once because the mixer, the speed of information itself, was running infinitely fast before everything locked into place. And what's really fascinating here is that this idea isn't just a clever patch for one problem. It's actually part of a much bigger framework that tries to reimagine all of fundamental physics through the lens of fluid dynamics. Just think about it for a second. If space really is a fluid, then maybe gravity isn't the curvature of spacetime. Maybe it's just the viscous drag on things moving through the fluid. And maybe fundamental particles are just tiny, stable whirlpools in this cosmic ocean. Dark energy? That could just be the background pressure of the fluid pushing everything apart. And all the weirdness of quantum mechanics? Maybe it's nothing more than the natural, chaotic turbulence you'd find in any fluid at the smallest scales.
What's so powerful about this way of thinking is that it tries to unify everything. Instead of having one set of rules for the very big, like general relativity, and another set of rules for the very small, like quantum mechanics, maybe they're just two different flow patterns, laminar and turbulent, of the exact same cosmic superfluid.
Which leaves us with a final, pretty profound question to chew on. Is the speed of light a true, unchanging law of nature, or is it just an emergent property, the local speed limit that got locked in when our patch the cosmos crystallized? While somewhere out there, in an infinite pre-geometric liquid, the real speed of information is something else entirely.